Hey there, we've made an eyelashes generator before, now it's about time we make an eyebrow generator. Now this is going to be a bit more complicated than the eyelashes one, so if you find that you have trouble, you can go and check my beginner-friendly geometry notes tutorial. I've actually got a whole course in this playlist. I'm gonna make this one a bit faster pace, otherwise we'll be here forever. That said, this is going to be a big one, so sit tight, grab a drink, and let's go. Like the eyelashes generator, our base will be a mesh line that I'm gonna snap to the face here. I'm gonna extrude some verts, roughly where the eyebrow is going to sit. We can always adjust that position. Now, to this line, I will add a geometry nodes modifier. Our first order of business here is to modify this mesh line slightly. First, I'll smooth it with a subdivision surface. 2 levels will be enough. Then I'm gonna convert it into a curve. It being a curve is going to be much easier to work with. We may need to adjust the curve tilt, so let's drop a set curve tilt node. And finally, let's capture some attributes that we'll need. We're gonna need the curve factor, okay, 0 to 1 gradient, and also let's get the curve tangent and the normal. Okay. Now, before we continue, let's look at some reference of eyebrows so that we know what the hell we're building, right? I've got some here. Now, this looks rather complicated, like where do we even begin here? Well, to make it easier, and not just with eyebrows, but with anything that you want to make, it would help to break down the problem into smaller tasks and see what features we can identify. So we've got the overall shape of the eyebrow. I found this picture, and shout out to whoever created this. Here we can see different eyebrow shapes. But overall it's thicker at one end and then it tapers off. You can kinda see that here. But apart from that, for realistic eyebrows, at the tail end here, there's a region of fewer hairs, but they kinda contribute to the whole shape. And even with very groomed eyebrows, you can still kinda see that. So we've got these two regions, the main shape, and then this lower density area that is wider and goes at the end, like this. Next thing, for our purposes, we're gonna have hairs that are tangent to the guide curve. We can call this flow, right? How tangent they are to the main direction of the guide. The other thing, you can kinda see, especially at the end here, how these lower hairs go up and the upper ones go down. They kinda converge towards the center. We can call this either convergence or clump. I'm gonna call it clump for simplicity. Obviously we're gonna have density, how much hairs are in a certain region. Also the length and thickness of the hairs. And finally, let's have a way to bend them so that we don't end up with perfectly straight hairs. Alright, if we do all of these features and combine them properly, we should end up with very acceptable eyebrows. So, let's go. First, we're gonna generate points around the guide curve here. Eventually, we're gonna turn them into hairs, but for now, let's just work with points. So, curve to points. And these are gargantuan. I'm gonna set point radius to make them smaller in the viewport. Alright, immediately let's start making some controls. I'm gonna grab the count, and this will control how many hairs we're gonna have. Now what we want next is to randomly offset these points around our guide curve. we obviously don't want them all bunched up here. So set position, and we're gonna offset their position by some random value. To have it offset in all directions equally, I will go from negative and put something small here, negative 0.01 to positive 0.01. Okay, and that way it won't go in one direction only. It's gonna hover around the guide. Let's output the seed control. To make this bigger or smaller, let's scale this offset vector, and this setting here is going to give us the shape of the eyebrow. So let's get this as the width control. Now what we can do is we can multiply this width with the factor of our guide curve that we've captured before. You can see how it creates this gradient of the thickness. To control this, we're gonna introduce a float curve. That way we can remap our factor to define the shape of the eyebrow. And we're gonna rely on the float curve a lot for control, so you better get familiar with it, okay? Now, this is all fine, but these guys are all floating in space. Let's attach them to the face. To bring up the face into the node tree here, we're gonna use an object info node. Select the face mesh, or better yet, make this into a control, so we can pick it from here. This is going to be relative, so as the character moves, we sample that moved position. Original is simply going to check the mesh at the origin. It's not gonna factor any movement. So what we want to set position of our points, and that position is going to be on the closest point of the surface of our character face. So we're gonna grab the face geometry and sample nearest surface. Here we have to say what exactly from that surface we are sampling. We want the position, which is a vector, and in that value we plug the position. This will give us, for every point of our cloud here, the nearest position on this surface. So then we set the position of our points to this sampled position. And there we go. They've now snapped to the face. Then we can adjust the shape some more. One thing here, if we also sample the normal of the surface, we can use it as the offset, but scale it down. We can use this to adjust the offset from the face. I'll make this into a control and multiply down this control even more because this is very sensitive. Okay, now this whole thing we can make into a group so that we can reuse. Apart from the geometry, I'll also capture the sampled position and the normal and output them because we might need them. There we are. Now these are going to be our main hairs, but let's create the secondary ones. I can just duplicate the set position here and it will give us a copy of the points. I'll also make a copy of the shape nodes because I want to have a separate float curve for its shape. And also let's multiply again so that we can have an independent control for the secondary width, like so. The other thing is, we kinda want this only at the end side of the eyebrow here, so we can delete these first points and just leave these ones. Delete geometry, and we need to feed it a selection. So let's see, if we grab the factor of our guide, we can use a less than to basically select all points with less than this value. Okay, and I'll make this into a control. I'll call this secondary factor. Then we can join this with the others with a join geometry node before we snap them to the face. There we are. Next, we're gonna deal with the density. The way we're gonna implement density, we're just gonna delete some of the points at random. The more we delete, the less density we have. To the main points here, I'll add a delete geometry. And now we're gonna select some points at random. So let's bring up a random value. This is going to be a random boolean. The probability is how much points we are selecting. At 1, it's gonna be all of them. To have our control, let's again plug the guide factor and a float curve. But here, high values means we are selecting more points to delete, which makes it less dense. We kinda want it the other way, high values to mean higher density. So we'll simply invert this. The easiest way is to subtract this control from 1, like this. Now we can control the density in a more intuitive way. Last thing is, let's have a way to decrease the overall density. So we'll mix this value with 1. Remember, 1 deletes all the points. So the mix slider will give us the overall density. Let's have that control. Main hairs density. Plug the seed here so that we randomize the selection. For the secondary hairs, we already have the delete geometry. We're just gonna append to the selection a random value. Again, a boolean. To combine two booleans, we should use an OR operation. This is a boolean math node with OR. Now, in general, these secondary hairs are usually less dense than the main ones, so if you want, we can say that it's gonna be half of the overall density. So 0.5 at max, and at 1 we're gonna remove them altogether. Right, so from 0.5 to 1, we can set the limits with a mix node. And this is going to be a control for the secondary hairs density. And again, the seed. Alright, before we turn these points into hairs, let's create two useful maps. We already have the guide factor. Another one that I want is a central gradient that is darkest in the center here, and then it becomes lighter as we move away from the guide curve. Basically the distance of any of these points to the guide curve. The further away, the greater the distance. Right, now how are we gonna do that? Well, we can use the geometry proximity node. This will give us the distance and the position to the closest element in a certain target geometry. This geometry has to be a mesh. See, if I hover over this, it says supported, mesh and point cloud. Our guide curve here is a curve, so we just turn it into a mesh. Curve to mesh. We're gonna look for the closest edge, and the source is going to be our point's position from here. Now, this doesn't look like it did anything, but believe me when I say it did, but these distances are so small that we can't really distinguish them from one another. What we really need is to normalize the distance values. The closest ones will be 0 and the furthest will be 1. Because right now, look at the distances. They are all really small. How can we normalize them? We need to grab this entire field and find the minimum and the maximum values from it. Thankfully, we have a very useful node for that, called the attribute statistic. If we plug the points in it, we need the distance as the sampled attribute. We get a lot of stats, but what we want is the minimum and the maximum. Then, to remap the distance, we use a map range. Minimum from minimum, maximum from maximum. And now the minimum is gonna become 0 and the maximum 1. There we are. So that's that, but another useful map we should have is a way to distinguish between the top half and the bottom of the eyebrow. Basically, for each point, it will give us on which side of the guide curve it is. So for that, if we take the vector from the point to the closest position on the curve, then compare that vector to the normal of the curve, we can achieve that. First off, to create that vector, or any vector, we're going to use vector math, subtract. If we subtract two positions, we'll get a vector pointing from the bottom position here towards the top, from here to here. So we want from the point position towards the closest position of the guide, which we have from here. So we've got that vector. Now let's compare it with the normal of the guide curve. By compare, I mean we're gonna take the dot product of the two vectors. For our purposes, if the vectors are pointing roughly in the same direction, the angle between them is going to be acute, so the dot product will give us a positive number. If they are pointing away from each other, we'll get a negative number. It's the cosine of the angle between them, but what we care about is the sign, because now we can compare less than or greater than 0, and we get this binary map. The reason we're using the normal is because it's perpendicular to the guide curve, and as long as we don't twist the curve, it's gonna be fairly consistent in the direction it points. That direction might be slightly up or slightly down. Wherever it is, what we care about is that these points will point with it and these points against it. If you don't get that effect, rotate the curve tilt by 90 degrees and it should work. This central map we can use to adjust the density of our eyebrow. Drop another delete geometry and a random boolean, and this map can be the probability. That way we have the eyebrow densest in the middle, and then a smooth fall off of the density. If we want to adjust that, we can use a mix node. Okay, now I think it's about time we create the hair curves. We're gonna instance on points, and what we want to instance is a simple curve line. This line is a bit too long, so let's decrease this. The scale here can serve as a control for the length of the hairs. Let's make another float curve setup, like the others, to have final control from left to right. Multiply this with the factor of the guide curve and use the float curve. And finally, it would be good to give some random variation to the length. We're gonna multiply the length value with a random value. Obviously, we don't want zero length hairs, so the minimum we'll set to 0.5, half of the length at most. This will shorten some of the hairs up to half length max. Right, there we are. Our next job is to align these curves to the brow shape. Now, this hair curve line is oriented along the Z direction, its main axis. It also has an X and a Y axis. We're gonna align the Z along the guide curve so the hairs are tangent to it. Then we'll pick one of the others, let's say the X, and align it to the normal of the face surface. That way we can use it as an axis to rotate or bend the hairs. So let's do that. To align some axis to a vector, we can use the Align Euler to Vector node. Here we can pick the axis and the vector. So as we said, the Z, we're gonna align to the tangent of the guide curve. And then this output goes into the rotation here. There you are. Then before that, let's use another Align Euler. This time the X, we're gonna align to the face normal. The rotation of this goes into the rotation of the next Euler. This second one doesn't change much now, but we can use the X-axis to rotate the hairs. I can demonstrate that with a rotate instances node. Because we've aligned the X to the normal of the face surface, they're gonna rotate lying flat on the face and not clip inside it. We can use this rotation to control the general flow of the hairs. As we talked about, some of them go across this way, and some of them are tangent to the guide. We can adjust that with the X rotation. First off, combine XYZ. In the X, we plug the guide factor. Then, as usual, drop a float curve. Now, this value goes from 0 to 1, but to get the full range of rotation, we need it to be from negative pi to pi. Pi is 180 degrees. From negative to positive, we get the full 360. So we map this float curve with a mix node, negative pi to pi. Now, this float curve will control the flow. If we set it to the middle, the hairs are tangent to the guide curve. Go up like this here to create this region. Okay. Now, we saw how the hairs converge to the center here. That was our clump attribute. To achieve that, we can rotate the lower hairs up and the top hairs down. Thankfully, we've created the mask between the two sets, so we can create the same float curve setup for rotation, and then add it to the flow value. add. Except this one we have to modify so that when we set some value, it will rotate the top and bottom hairs in opposite ways, so they converge. That's easy, multiply this with our mask. But now, because our mask is 0 here, it doesn't rotate. It has to be -1. Remap our mask. Not 0 to 1, but -1 to 1. Great, except the hairs in the middle should barely rotate, otherwise, well, this doesn't look right. We need these to stay still, and the other ones further away to progressively rotate more and more. Well, remember we have this mask. If we multiply this whole value with this mask, it will be smaller in the center. So let's do that. And there we are. We can control the clumping from the float curve. Now, right now our hairs are perfectly straight. We should give them some bend. How can you bend a curve? Well, first of all, these are instances, so let's realize them to curves. Okay. Then we need more points on these curves, so resample curve, about 12 points per curve. Now that we have more points, we can bend the curves with a set position. We want to rotate the position, okay? Then vector rotate. We are rotating the position of the curve points. Now we need to adjust the axis and the center. The axis is going to be the normal of the face, right? So that we don't clip inside the face as we bend. And the center is going to be the start of each hair, which is the position of the points that we use to instance. Now, the reason it's not working is because these two attributes kinda got lost when we realized the hair curves. We need to transfer these two to the instances. So let's go back to this node group and capture the position and the normal on the geometry with a capture attribute. And there, it works now. Okay, so now we've created something similar to this, except here we rotated instances, where here we rotate all of the points of the realized geometry. Because we are rotating each point individually, we can rotate them differently. How differently? Well, if we have a curve with a bunch of points, if we rotate this point a little bit, this one a bit more, this even more, we will get a bent curve. So we need a gradient of the rotation value. Well, that's the curve factor. Spline parameter in the angle, and there we are. To control this, we multiply, but they're all bending in one direction. We need to multiply this with a random value. This will be from -1 to 1. But as you can see, these hairs became kinda messy. Well, that's because this outputs a random value for each point, so every point goes at a random direction. We need a random value for each spline, so this ID we can evaluate on domain, not points but spline. Okay, now these curves are bent by a random amount at a random direction. To control how much, we just multiply this. And we can even bring a float curve setup to control the bend across the eyebrow. With that, there is one key feature before we give those curve thickness, and that is we need to attach the curves to the face. To attach all these, we will use the same method to snap them to the surface like we did for the points. So first off, set position so we can move them. Then remember, sample nearest surface. Let's bring up the object info again. Face mesh, we already have an input for it. And we're gonna sample the nearest position. But this snaps everything. We can actually mix between this position and the snapped position. And the mix factor can be spline parameter factor. We've snapped just the root, a float curve here, and we can adjust the attachment profile, the shape the hair makes when it lies on the face. Alright, that's the hair curves. Now let's give them thickness. Curve to mesh, and for the profile we will use a curve circle. Make the radius of it very small. Also, because these are so thin, we don't really need many segments. Even 3 or 4 are enough. To these, we can add a set curve radius to adjust the shape. The radius is a spline parameter factor, and we can add a float curve to it. Then just create some hair shape, like so. If we want, we can multiply this with the guide factor, so we can have a control for the thickness across the eyebrow. Now you can probably see they're a bit jagged. Well, that's because of this mix here. We can actually smooth these curves up a bit. For that, we can blur this vector, but we don't want to blur all the points, just the center ones, so it keeps the ends in place. So to the blur weight, we can use the spline factor and remap it with a float curve, such that only the center will have any value. The ends should be at 0. There we are. And you know what? This should be enough for the geometry. Now we should set up some material. Add a set material node and pick out any material. Now I'm gonna leave the shader up to you. It's not gonna be something complicated because it's just some hairs. Pick out the color and roughness and you've done 90% of the job. What I want to show you is how to fade the roots. We did something similar with the eyelashes. Here I'll just make something simpler. To the curves here, before the curved mesh, let's store a named attribute. This attribute will be the spline factor. I'll call this hair's fade. Now in the shader, add an attribute node, the same name, hair's fade, and we have the same shape. Then this goes into the alpha. You can see it fades in the roots. Without it, it looks very abrupt. With it, I think it looks better. You can adjust this with a color ramp. And that's it, really. We have a wide range of controls, and with these float curves, we can fine-tune the shape. We can add a mirror modifier to get the other one. Or, because my face isn't symmetric, just create another mesh line and apply the eyebrow modifier. Just if you find that it doesn't look the same, we may need to invert some of the directions of the guide curve. To the beginning here, where the starting curve is, we can place a reverse curve node. Okay, but also we need to flip the face normal. And by that, I mean to scale it by -1. Let's make a switch for both of those. This is a switch vector. Let's call it flip normal. And the guide direction as well. Flip direction. There we are. You can adjust the shape in edit mode. To get this to move with the character, first we should parent it to the head. And then, to get any motion from any shape keys, we can add a surface deform modifier. Before this one, select the face mesh and bind it. There. But yeah, play around with this. I will upload this node group to my Gumroad. You can get it for free, along with the eyelashes one, which by the way I've updated a bit also. It should work the same, just a little bit better now. If you want to support me, I've also coded an add-on that you can use with these two node trees. It will make it a lot easier to import the setup into a new file and also control the float curves from an organized UI panel, instead of digging around in a node tree. It will also work with the eyelashes. So if you're interested, links are down below. It will help a lot. If you have any questions, feel free to let me know in the comments. Alright, good luck and see you next time.